Assalamualaikum warahmatullahi wabarakatuh. My name is Rendy Akbar Rianto. I'm an information system student from Mercubuana University. Today, I will be presenting on the topic of how memory is measured. When we look at the specifications of an electronic device, such as a computer, laptop, or smartphone, we often see abbreviations like MB, GB, or TB. Although many of us are already familiar with these terms, people new to the world of electronic devices may find them confusing. The text commonly displayed on electronic devices is known as memory. The main function of a computer memory is similar to that of the human brain, which is to store, analyze, and process incoming data. The performance and operation of a computer heavily rely on its memory, which make it a critical component of the device. Memory in computer is not limited to one location. It is distributed across several hardware components, each with its own unique purposes and functions. For instance, in devices such as computers and smartphones, there is memory allocated for storing user data and applications. At the same time, there's also memory responsible for managing the execution of application on the device. Next, let's talk about how memory works. However, before going deeper into that discussion, it's essential to familiarize ourselves with what binary numbers are. Binary numbers are a fundamental concept in computer science and digital electronics. Unlike our everyday decimal numbering system, which uses 10 digits from 0 to 9, the binary system employs only two digits, 0 and 1. Each digit in a binary number is referred to as a bit. The data in memory is represented as binary numbers, encoded into specific sequence by information processing instructions. More complex instructions can later be used to store multimedia data like image, videos, audio, and so forth. We have likely heard the term byte before, right? Byte is a collection of an information contained with a single cell. As mentioned earlier, each memory location has distinct places, and all of this is written in hexadecimal base 16. The CPU tracks the memory location and carries out the process of reading and writing data. Furthermore, memory chips are equipped with capacitor and transistor, arranged in rows and columns. Capacitors serve as storage elements while transistors act as switches. This is a memory storage capacity table. As you can see in the table on this slide, moving downward indicates that the storage capacity is larger. Okay, let's get to know them a little. The first unit is a bit, which is the smallest unit of data, consisting of only 0 and 1. Next, there's a nibble, which contains 4 bits and is rarely discussed. Then comes the byte, which is a unit consisting of 8 bits. Bytes are more commonly used and more well known compared to nibbles. For examples, to represent the letter A, we have a collection of bits as follows. This value is what we refer to as a byte. From the table on the slide, the units that are more relevant to us today are the kilobyte, megabyte, gigabyte, and recently there are home computers that have reached the terabyte range. On the other hand, petabyte, exabyte, zettabyte, and yottabyte are still limited to instances, companies, even storage and competing with more massive usage and capacities. Okay, thanks for your attention. That's all for me. Wassalamualaikum warahmatullahi wabarakatuh.